Algebra, welcome. The next thing in this inequalities unit is going to be compound inequalities, okay? Very similar to absolute value in the fact that you're going to have two actual graphs, okay? And then from there, you'll combine them and stuff like that, which you'll get used to putting them in one graph. Sometimes you'll make two because they'll be looking a little bit different. But for the most part, you're going to get two solutions, you're going to graph them, and at one point they're going to be on the same graph. For now, we're going to do separate graphs just to kind of see and then put them together from there. If you want to get colorful, like you can kind of see, we have two things going on. Like this could be one color, that could be another color. Go for it, but you just need to make sure your answer is obvious. So there's three types of these. There's an and statement, okay? There's an or statement, and there's one that's kind of combined. This is more considered an and statement, okay? When we look at these, if you think about it, an and statement should mean that it has to be true for both things, okay? An or statement means it needs to work for one, or it needs to work for the other. So when we look at this, we just solve each inequality like we normally would. Add the 3, we get n is greater than -1. Okay? Very simple. I'm going to go kind of quick, so if you need to pause just to catch up. Divide by -2 in the second part. Okay? We get n. Flip the inequality because we divided by negative, so it's n is less than. Negative divided by negative is a positive, and we'll have a positive 8. Okay? So then we graph each of these. Now I'm just going to make small inequality lines. Okay, I'm not sure if I mentioned this before, but when we make our own graph, put the number you have in the middle, -1 and 8. Okay, we got an open circle here. You can put a 0 and -2. You probably should do that just so you not mess everything on the line. And then n is greater than -1, so that means this one's going to go this way. And then n is less than 8, so open circle on 8. Less than 8, okay? And then we simply, again, just pause if you need to copy on the graphs. And then we combine these, okay? The way we combine these, we take our smaller number on the left, -1, our larger number on the right, 8. I don't care where they're at in the number line, just put them on there, okay? And then obviously, these are gonna be shaded next to each other. This one worked out nice that our smaller number graph was on the left and right, so you can kind of just see it there already. Okay, but we have an open circle, and they're going to be shaded towards each other. Okay, so that means my common area, because it's an and statement, is going to be that middle. Now you'll have kind of other shading here if you would have put it as one right away, but you'll notice that the common area is in the middle. Okay, maybe we'll do one graph instead of two on the last one. Pause if you need to. B. A little bit more difficult. It's just two steps for each of these. It's nothing bad. So solve the two-step equation or inequality. Subtract the 7. We get -2x is less than or equal to 6. And then we'll divide by that -2. Flip the inequality to a greater than or equal to. And then we divide and get a -3. That is 1. If you wanted to graph it right away, you could. We have -3 in the middle. -4, -2. It's a closed circle. And we're shading the greater than side. So we shade the right. Again, it's a closed circle because it's or equal to, so that means it needs to include the -3. Okay, and then this one, subtract your 12. We get 5x is greater than 25. We then divide by the 5. We get x is greater than 5. And we graph that one. 5 in the middle, 4, 6. It's an open circle. And we're going to shade to the right. Now, you'll notice both of these are going the same way. Okay, so the real solution here is it either needs to work for one or the other, but it could work for both. Okay, it doesn't need to work for both, it needs to work for one or the other. So when I graph this, okay, I have a -3 here, I got a 5 here, okay? The 5 is going this way. So that means some of my solution needs to be more than 5, okay, some of it. Any solution that will work for this right part needs to be greater, if it could be 5.1, and it will work here, okay? But then if we look at this one's also a greater than, so this one's gonna be shaded to the right as well. So what our real solution actually is everything including -3 and greater, because if we think about it, if I took 0 for example, 0 is gonna work for this left one, because we'll have 7 is less than or equal to 13, and that works. 0 does not work for that one, and that's fine, because we need one of them to work. It's either one or the other. If we looked at something like 10, if I plugged in 10, this one we would get 62 is greater than 37, that works. This one we would get negative 13 is less than 13, that one works as well. Or doesn't mean they both need to be true, but they both could be true. Okay, so this is my solution. Anything greater than or equal to -3 is going to work, because it needs to be for this one or this one. It just happens to be that anything for here is also going to work here. So it kind of works out that way. Pause if you need to. And then the last one, okay? When I look at this, you can see that there's actually two separate inequalities. We have -4 is greater than 3x plus 2. And then we're going to rewrite the 3x plus 2. Okay? So now I have 3x plus 2 is greater than 7. Okay? What we kind of do is we kind of hide the right inequality. There's one, and we hide the left one, and there's the other. Okay? And then we solve it that way. Now, some people might get confused because this is going to be backwards, but it's not that bad of a thing. Subtract 2, we might as well do the same steps on everything. So I get -6 is greater than 3x, and I get 3x is greater than 5. And then we'll go ahead and divide by the 3. So I'll get -2 is greater than x, or you could say x is less than -2. And then this one will get x is greater than 5 over 3. Now I'm going to put this on one inequality graph, okay? So again, your smaller number goes on the left. So I'll have -2. And this one, who cares that's a fraction? Just write the fraction. It goes on the right, 5 over 3. Both of them are open circles. And then we just look at this, okay? X is less than -2, so that's going to go this way. And x is greater than 5/3, so it's going to go that way. Okay? And that's our answer. Pause if you need to. Otherwise, that wraps up for this. The next thing is going to kind of be a mass review of all the inequalities, but you kind of need to identify what's going on and just solve them like they're supposed to be solved. So until next time, have a good one. I'll see you then.